Chapter 7, Breaker Control and Auto Reclosing. There are a number of basic requirements for circuit breakers which are desirable in their control circuits. Control of the closing, control of the tripping, trip-free, anti-pump, and reliabilities. These features can be found in motors, solenoid, springs, stored energy, and pneumatically operated breakers. Let's take a closer look at these features. When we initiate a trip stroke, it means that a signal must be provided to trip the breaker. This may involve energizing a solenoid coil to trip a latch, or in the case of air blast breakers, to admit air to the blast valves and contacts. Initiating a trip stroke also involves initiating other things to happen during the tripping of the breaker, such as anti-pump, etc., etc. We'll talk a bit about those in a few minutes. Cutoff is a means of automatically disconnecting the trip coil once a trip signal is sent. Primarily because you don't want to keep the trip coil energized because it could heat up and burn out, but also a lot of automatic things could happen once a trip signal is sent. There could be an auto reclose coming close on the heels of the trip signal, and if the control mechanism to trip the breaker is manually operated by an operator, chances are he's going to hold that trip signal in a little bit longer than is required and could cause the breaker to trip again if it was automatically reclosed. So anyway, once a trip signal is sent to the trip coil, there's a cutoff that automatically disconnects the trip coil from the initial trip being sent. The trip-free function. When closing a breaker, the closing device, for example, a solenoid in a solenoid-operated breaker, is energized and the plunger operates through the linkage to close the breaker contacts. At the end of the closing stroke, appreciable time is required to de-energize the solenoid coil. In the event that the breaker has been closed on a faulted circuit, it must be reopened as quickly as possible. If a breaker can trip automatically upon receiving a trip signal before the closing operation is complete, it is said to be trip-free. Various arrangements are provided to obtain trip-free action. Solenoid-operated breakers are sometimes provided with a collapsible linkage. Pneumatically operated breakers may be equipped with two latches, one of which is unlatched during normal trip operation and the other is only unlatched for a trip signal when the breaker is closing. Other breakers use large dump valves to quickly exhaust the air under the closing piston. Many motor-operated breakers obtain a fast trip-free action by use of a relay energized from the trip circuit to open the closing circuit. These methods would be known as mechanical trip-free, pneumatically trip-free, and electrically trip-free, respectively. Anti-pump. When a breaker is closed and a trip-free operation results, the close and trip stroke will be completed in a very short time. For a modern pneumatically operated high voltage breaker, the complete operation will take less than 1/2 of 1 second. Thus, it's quite likely that the operator will still have the control switch in the closed position. Means must therefore be provided to prevent the breaker from closing a second time, even though the operator is holding the control switch in the closed position. This is usually accomplished by the use of a sealed-in relay, which can only be released by the opening the closing control switch. When this feature is incorporated in the control circuit, the breaker is said to be pump-free or anti-pumping. Following a trip-free operation, of the breaker, the operator must open the control switch before a second attempt to close the breaker can be made. We will be looking at the anti-pump circuit to see how it works in a couple of slides. Reliability. A circuit breaker is a protected device. It will be called upon to open faulty circuits infrequently. However, while it may stand inoperative for a long period of time, it must be relied upon to operate correctly in time of trouble. Reliability for such a protective device is essential. For this reason, a battery supply is always used to provide the tripping power and in most cases the closing power for a breaker. The control circuits usually have a separate trip and close bus. This is to give extra reliability to the trip circuit. On 115 kV and above circuit breakers, there's usually dual trip buses. Thus, if a closing control circuit fuse fails during a closing stroke, the trip circuit and or circuits associated with the trip function will not be affected. This is what a typical DC control circuit for a breaker might look like. You'll notice that the closing circuit has a separate fuse supply than the trip circuit. They are independent of each other, yet they control the same breaker. Okay, let's take a closer look at one of these control circuits just to see how it works. This is the portion of the closing circuit that is associated with the anti-pump logic. This is the basic anti-pump circuit shown at rest with the breaker open. Notice that relays 52X and 52Y, as well as the breaker close coil, are de-energized. Since the breaker is open, the A Pali switch is open and the B Pali switch is closed. If the breaker is given a close signal, say from the operator close control, and held on, 52X picks up through 52B Pali and closes its contacts, bringing positive to the breaker close coil. This will close the breaker, opening the B Pali and closing the A Pali switches, energizing the 52Y anti-pump relay. This relay opens its normally closed contacts, 52Y, de-energizing and opens the closed circuits to it. The other 52Y normally closed contact drops out the 53X relay. The 52Y relay seals itself in and remains sealed in as long as the closed switch is held on. This holding of the close switch is not necessarily a long time, but if the breaker is feeding a permanent fault, the breaker will trip in a fraction of a second. But since the 52Y anti-pump relay is sealed in, the close signal will not again reach the breaker close coil, preventing the pumping action from taking place. The breaker remains open. Once the close switch is released, breaking the positive seal in to 52Y, then all goes back to normal. In the case of high voltage circuit breaker reclosures, the protection for, say, line protection will immediately, upon tripping, at the same time initiate an automatic reclose feature, which can be selected or deselected by the operator when operating the station, either remotely or on site. The reclose relays themselves that provide the functioning for reclosing the relay are associated with a breaker, and there may be 2 or 3 breakers associated with the tripping of a line. So it's the job of the relays that are associated with a breaker to provide the various checks and balances needed to reclose line into circuits. For example, if we're energizing, if we have one breaker tripped and on either side of the breaker it's energized but out of synchronism, you certainly don't want to reclose the breaker. It would be the same thing as we were closing into a dead short if it was out of synchronism. Or if the line, you wanted to just check and make sure the line is dead, so you want to have a relay that would check for undervoltage conditions before reclosing. If there wasn't undervoltage, then perhaps you wouldn't reclose the line. Anyway, the CUH90 SynchroCheck Reclose relay is an old school relay. Again, a lot of them are still in service today, and they are being replaced by the more modern intelligent electrical devices, or IEDs, that are coming on the market. And we'll look at those which are a little bit more compact and a little bit easier to set up. However, I thought I would give you a quick look at both. This is no way intended to give you a full-blown analysis of the relay. It's simply to give you an introduction as to what it is capable of and how it's selected by the system. As I said, there are some pre-selected conditions involving the BBC CUH90 relay that are electrically checked prior to reclosure. And these items are undervoltage of the line plus time, and that's usually 10 seconds. In other words, if the line has been tripped and it's under voltage for beyond 10 seconds, then this is a selection for reclosing this breaker back into position because the line is dead and you want to energize it. Another more sophisticated way of closing the breaker is to synchrocheck across the breaker. In other words, if you've got voltage or power on both sides of the open breaker, this relay, if it is selected for synchrocheck, will actually check the synchronism across the breaker, and if all three phases are in phase on either side of the breaker, then the relay will allow the breaker to reclose. Sometimes you want to just measure for voltage presence plus time of 1 second. This is a selection that is available. You can also select a long time by itself or a short time. One of these 5 selections can be made, and this relay will provide the intelligence for checking any one of these 5 items. So as I said, the SynchroCheck supervision is provided to check the voltage, that voltage is present, first of all, on both sides of the open breaker, and the 2 voltage levels are within limits. In other words, they have to be up to at least within a certain percentage of each other, and that the phase angle between 2 voltages remains less than a preset value for a prescribed length of time. The Brown-Boveri SynchroCheck relay consists of 4 main elements. The CUH element, this is a phase checking element which looks at the red to white voltage on each side of the breaker and determines if the phase angle is within a preset value. The operating range of the element is adjustable from 5 to 25 degrees and can be modified to operate for a range of 10 to 60 degrees. The VG element is a phase angle between 2 input voltage is measured, and if that voltage is 180 degrees or one of the input voltages are equal to 0, the CUH element remains in a non-picked up state. The VG element is designed to respond to the vector addition of 2 input voltages, V1 plus V2. The PA timer element is basically a 0 to 5 second adjustable DC timer relay, which is preset to operate in approximately 2 seconds. With the CUH element in neutral position and the VG element picked up, the PA timer is is in turn picked up, which closes its contacts 2 seconds later to enable a circuit breaker reclose. The P8 relay, this element is simply a DC relay that picks up when the CUH element swings left or right if the input voltages are out of phase by a preset angle. The CUH contacts will close, which in turn supplies positive DC to pick up the P8 coil. The normally closed contacts from the P8 relay are connected in series with the PA timer coil, which effectively blocks the pickup and prevents the circuit breaker from auto reclosing. And this relay has 2 sets of logic circuits. It has an AC side, which is connected to the PTs of either side of the breaker, and it has a DC side connected to the battery control circuits and other auxiliary relays, which will provide intelligent selecting for the reclosing of the breaker. We're going to look at only a partial bit of the control circuit, the DC control circuit, which also controls applying the AC quantities to the CUH90 relay. It's certainly by no means a complete set, but I thought I would have a peek at just some of the control features that go on ahead of the automatically reclosing of the breaker. First thing that has to happen in order for auto reclosure to happen is there's a selector switch either on a panel or on a remote control system that has to be selected for automatic reclosing to be in place. In other words, it has to be selected for auto reclose. If it's not selected for auto reclose, nothing will happen. So this switch a lot of times is on a local panel that the operator turns it on, which selects auto reclose. The next thing is that the auto reclose has to be initiated from a protection. In this case, it's the line 1 protection that took the breaker out in the first place. Selecting it, or these contacts will actually select for auto reclosure again, hoping that the fault will be cleared. If, say, it was lightning, it has a chance to clear, then the trip relay will automatically initiate a reclose with one of these series of contacts. The other contacts that are in parallel with this would be from other either line protections or other feeder protections that would initiate a reclose. In this case, we're only talking about line 1 protection. The other thing that there are several checks and balances that may or may not be in place. One of them is that the air pressure is good inside the pneumatic circuit that causes the breaker to close. If the air pressure is not there, then reclosing won't be attempted because you could get a partial reclose, which would not be good. Then if all these functions are in place, then the 7963A relay will pick up and it will seal itself in. Once this relay picks up, then it also initiates a pickup of the AC quantities to feed into the CUH90 VB relay, which is the voltage comparison relays before or as is checking for reclosing. In the AC part of the relay, the 79A-L1 picks up and connects the AC to the CUH90 sensing coils. Before that happens, there is another check that takes place, and that is the line disconnect switches. If the line disconnect switches are closed, then it allows reclosure to continue. If the disconnect switch is open, of course, there's no need to invoke auto reclosing because it won't do anything except close the breaker, and you don't need to close the breaker if the disconnect switch is open. The two voltages on either side of the breaker then energize the AC coils of the CUH90 relay. The VG contacts close when voltage vectors are added to the threshold. If the vector sum of V1 and V2 are 0 or 180 degrees out of phase, the VG contacts remain open. The CUH contacts open when the phase angle is small, close when the phase angle is large. P8 then picks up opening the normally closed contacts, blocking the PA relay. As I said, this is only a partial look at the control circuits for the CUH90. It gives you a partial look as to the initiation of breaker reclosure and applying the AC quantities to the sensing relays and initiating some of the DC timers. What happens in order to give you the undervoltage of the line plus 10 seconds time delay, or a synchro check, or voltage presence plus time and long time and short time? These functions are all dialed in after the fact, and they're provided by the DC circuitry and logic that the CUH90 would be feeding into. As I said before, the CUH90 relay is definitely an old school relay and has a singularity function, that is to provide reclosing for the breaker. A lot of relays now that are coming on the market are almost one-stop shopping. They are multitask and multifunctions, and such is the case, and I'm only introducing this Schweitzer relay, the SEL 751 relay, which is providing feeder protection in the way of overcurrent and power flow, and then you can see all the functionings that it does there. One of the things that it does do, along with all the protection that it provides, is that it will provide automatic reclosing. And I just wanted to show you it here, that a lot of the newer IED type relays that are out there come complete with auto reclosing. Some of them have single pole tripping and reclosing. Some of them just have the 3-pole reclosing. This one, you can see it does synchro checks and it does the auto reclosing as well. So there are other relays out there, as I said, by other manufacturers such as Siemens and the other various companies that produce these type of relays, and they all usually come complete with auto reclosing attached to it, and it's a lot easier to select the functionality of these newer relays. That ends Chapter 7.